The scientific method refers to a way by which scientists examine and explain the world. In this video, I will list the steps involved in the scientific method and look at examples regarding the question of spontaneous generation. The scientific method can be simply considered in 4 steps. First, observations lead a scientist to ask questions about the observations. Second, the scientist proposes a hypothesis to answer the questions and explain the observations. Third, the scientist designs experiments to test the hypothesis. And fourth, the scientist considers the results of the experiment and accepts, rejects, or modifies the hypothesis. Additional experiments are conducted to verify accepted or modified hypotheses. Experimental design is a rigorous and important part of the scientific method, and each experiment varies in its details. In many experiments, good experimental design involves the effect of some intervention or process on one group that we call treatment subjects, and withholding that treatment from control subjects. Some examples may clarify these concepts. Aristotle in the 4th century BC observed that maggots appeared on meat left in the air. He hypothesized that spontaneous generation explained this observation. Spontaneous generation is the idea that living things can come from non-living things. The hypothesis can be stated as, meat spontaneously generates maggots. Aristotle didn't perform experiments to test his hypothesis, but in the late 17th century AD, Francesco Redi did. Redi put raw meat in 2 jars. He left the first jar open and tightly sealed the second one. The open jar is the control, and the closed jar is the treatment. Within days, Redi observed flies and maggots on the meat in the control jar, but no maggots appeared on the meat in the sealed treatment jar. Based on his experiment, Redi rejected the hypothesis that meat spontaneously generates maggots, and he then proposed a new hypothesis. Maggots only come from eggs from flies. He tested this hypothesis with another experiment involving an open jar and a jar covered with gauze. Once again, maggots appeared on the meat in the open jar, and in this case, maggots appeared on the gauze, both places where flies had landed and laid eggs. He accepted the hypothesis. After many similar experiments, most scientists rejected the hypothesis that larger living things could arise spontaneously. But many still hypothesized that microbes, which are smaller and simpler, could spontaneously generate. This seemed to be backed by experimental evidence. For example, in the 18th century, John Needham boiled nutrients such as meat and vegetables to make a broth. He let the broth cool and corked his treatment flask. Within days, both the treatment and control broths were cloudy with microbes. Since boiling kills things, he concluded that his boiled broth spontaneously generated microbes. He accepted the hypothesis that microbes can spontaneously arise from non-living chemicals. 50 years later, another scientist, Lazzaro Spallanzani, conducted a similar experiment, but his results challenged those of Needham. Spallanzani boiled broth for over an hour and melted shut the top of the treatment flask rather than sealing it with a cork. Spallanzani's treatment broth remained clear. No microorganisms developed. Spontaneous generation didn't occur. He suggested that Needham hadn't boiled the broth long enough, or that the cork allowed microbes to enter. The debate continued when supporters of Needham said that Spallanzani's flask lacked enough air for spontaneous generation. By the 19th century, there was experimental evidence for and experimental evidence against the hypothesis of spontaneous generation. Louis Pasteur settled the debate. Pasteur used flasks of boiled broth similar to those of Needham and Spallanzani, but Pasteur left his flasks open to the air in a unique way. He bent the tops of the flasks into an S shape, making a swan-necked flask. This allowed air to diffuse from the opening down the neck into the broth. Dust particles in the air can't make it to the broth. They settle in the bend in the glass. Even after 18 months, no microbes appeared in Pasteur's flasks. Spontaneous generation didn't occur. We reject the hypothesis. In summary, the scientific method involves 4 steps: asking questions about observations, proposing a hypothesis to explain the observations and answer the questions, conducting an experiment with controls to test the hypothesis, and then accepting, rejecting, or modifying the hypothesis. Based on the results, experiments are repeated or new experiments are designed.